everyone, welcome to my channel SizeApp. So this video is another in the series for AWS and for preparing you for the certifications. Today we'll be covering one of the most exciting topics ever. Not really, it's networking and content delivery in AWS. So if you go to docs.aws.amazon.com, then you'll see that under network and content delivery there is so much information, but there are only a couple, I would say about 5 or 6 that you need to know quite well. So before I begin the video, I wanted to ask you to like, subscribe, and comment on my videos so that I can continue making them. It really does make me feel happier. So let's get started. First is API Gateway. There is CloudFront, Direct Connect, Route 53, VPC, VPN, Elastic Load Balancing. So these are core components of networking and delivering and content delivery in the cloud. Let's get started with API Gateway. So as the name suggests, this is a gateway for it's a service that allows. It's a AWS service for creating, publishing, maintaining, monitoring, and securing your REST and WebSocket APIs, REST and WebSocket APIs at any scale. So the API developers can create APIs that access AWS or any other web services, as well as data stored in the cloud. So as an API gateway, it's a gateway for you to access the APIs. You can create APIs for use in your own client applications or apps as they're called. So, or you can make your APIs available to a third-party app developer. So the API gateway creates REST APIs that are HTTP based, that adhere to the REST protocol, which enables stateless client-server communication. And I know these are higher concepts, but for now, just go with the video and I will dedicate another video to explaining REST versus SOAP, server stateless versus stateful. So for API gateways, it's HTTP based. It adheres to the REST protocol. It's implement standard HTTP methods such as get, post, put, patch, and delete. So it adheres, in terms of the API gateway creating WebSocket APIs, it adheres to the WebSocket protocol, and it also helps in routing incoming messages based on your message content. So features of API Gateway that you should be very familiar with are support stateful, which is the WebSocket, and stateless, which is the REST APIs. It's powerful, flexible authentication mechanisms such as identity and access management policies, Lambda authorizer functions, and Amazon Cognito user pools. It offers developer portal for publishing your APIs. It allows Canary release deployments for safely rolling out changes, CloudTrail logging and monitoring API usage and API changes, CloudWatch access logging and execution logging, including the ability to set alarms. It also allows the ability to use AWS CloudFormation templates to enable API creations. It supports your custom domain names. It's integration with AWS WAF for protecting your APIs against common web exploits. It also allows integration with AWS X-Ray for understanding and triaging performance latencies. There, you can access it through the management console, software development kit, API Gateway version 1 and 2 APIs, command line interface, or even Windows PowerShell. So that's all you need to know for API Gateway. It's like the guard. It acts like a gateway to all your APIs. Next, let's talk about Cloud Map. So Cloud Map, it's a fully managed service that you can use to create and maintain a map of the backend services and resources that your application depends on. So Cloud Map works like this. You can create a namespace that identifies a name that you want to use to locate your resources, and also specifies how you want to locate resources using AWS Cloud Map Discover Instance API calls. Then you create an AWS Cloud Map service for each of your resources. And after that, your application adds a resource, and once your application needs to connect to the resource, it calls to the instance that you created in your Cloud Map and specifies the namespace and service that are associated with the resource. It's Cloud Map works very closely with Elastic Container Service, which is Amazon ECS. As a new container tasks spin up or down, they automatically register with Cloud Map. So you can use a Kubernetes external DNS corrector to integrate Amazon Elastic Cloud Service for Kubernetes with Cloud Map. You can also use Cloud Map to register and locate any cloud resources such as EC2 instances, Dynamo database tables, S3 buckets, SQS, or APIs deployed on top of your API gateway, amongst many others. So that's all you need to know for Cloud Map. Now let's move on to Direct Connect and load balancing, which are very important concepts. So Direct Connect. AWS Direct Connect links your internal network to a AWS Direct Connect location over a standard Ethernet fiber optic cable. So one end of the cable is connected to your router and the other to an AWS Direct Connect router. So with this kind of connection, you create a virtual interface directly to public AWS services, for example, S3, or to a Amazon VPC virtual private cloud, which is something we will discuss a little later. And this helps bypass internet service providers in your network path. So with AWS Direct Connect, location provides access to AWS in the region with which it is associated. You can also use a single connection to a public region or AWS Gov Cloud in the US to access AWS services in all of the public regions. So Direct Connect components include connections, which it creates a connection in the Direct Connect location to establish a network connection from your premise to the AWS region. Then you have a virtual interface which enables you to access AWS services. A public virtual interface enables access to public services such as S3. A private virtual interface enables access to your VPC. So that is Direct Connect. Now let's move on to Elastic Load Balancing. And you will hear this load balancing term quite a bit when architecting in the cloud in AWS. So Elastic Load Balancing distributes incoming application or network traffic across multiple targets such as EC2 instances, containers, IP addresses in multiple availability zones. So Elastic Load Balancing scales your load balancer as traffic to your application changes over time. It can automatically scale to the very vast majority of the workloads. So some of the benefits include it distributes the workloads across multiple compute resources such as virtual servers. It's using a load balancer, it increases the availability and fault tolerance of your applications. Again, these two words are very key. You can add and remove compute resources from your load balancer as your needs change without disrupting the overall flow of requests to your applications. You can configure health checks which monitor the health of your compute resources so that the load balancer sends requests only to the healthy ones. You can also offload the work of encryption and decryption to your load balancer so that your compute resources can focus on their main work. There are some features that you should know. There are three types of load balancers. There's the application load balancer, there's a network load balancer, then there's a classic load balancer based on your needs. And I will deep dive into all of this once I dedicate an entire video to Elastic Load Balancing. And some of the related services with load balancer, as you can imagine, would be the EC2 instance, which allows virtual servers that you can run your application in the cloud. You can configure your load balancer to route traffic to your EC2 instances. There is EC2 auto-scaling, ensures that you're running your desired number of instances, even if an instance has failed. EC2 auto-scaling also enables you to automatically increase or decrease the number of instances as the demand on your instances change. So if you enable auto-scaling with Elastic Load Balancing, instances that are launched by auto-scaling are automatically registered with a load balancer. So likewise, instances that are terminated by auto-scaling are automatically deregistered from the load balancer. There's a certificate manager. When you create an HTTPS licenser, you can specify certificates provided. It works well with CloudWatch, enables you to monitor your load balancer and take action as needed. There is ECS, enables you to run, stop, and manage your containers, your Docker containers on a cluster of EC2 instances. You can configure your load balancers to route traffic to your containers. Route 53 is something we will discuss later. It provides a reliable and cost-effective way to route visitors to websites by translating your domain names into the numeric IP addresses that computers use to connect to each other. For example, if you translate Amazon.com into the numeric IP address of 192.0.2.1, it always starts with IPv4 version 4 always has like a 3-digit, then a 111 digit. So AWS assigns URLs to your resources, such as load balancers. You might want a URL that is easy for users to remember. So to map your domain name to a load balancer, this service can help you. It also connects with WAF, which with your application load balancer to allow or block requests based on the rules in the web access control list. So that is what load balancing is. As the name suggests, it balances the load. Then the next key concept to discuss is Route 53, which is a little complicated to understand. Route 53 is a highly available and scalable domain name systems web service. You can use Route 53 to perform 3 main functions in any combination: domain registration, DNS routing, and health checking. So for now, I will leave Route 53 at that. Just remember that it helps perform the main functions of domain registration, routing, and health checking, and it connects the domain name to the IP address. Just as a side note, all the computers on the internet, from your smartphone or your laptop servers that serve content for massive retail websites, communicates with one another by using numbers. So these numbers are known as IP addresses, and there are two kinds. There's a version 4 and a version 6. Version 6 is very lengthy, like 2019, and you'll get this huge lengthy number with intermittent letters. And then you have the version 4, which we know more commonly, 192.0.2.44, for example. So that's 3 digits, 1 digit, 1 digit, and 1 or 2 digits. So this is how internet traffic is routed to your website, and Route 53 helps translate those words like the domain names like Amazon.com, Netflix.com to IP addresses. Now let's move on to VPC, which stands for Virtual Private Cloud. A virtual private cloud enables you to launch AWS resources in a virtual network that you've defined. So this virtual network closely resembles a traditional network that you would operate in your own data center, with the benefits of using scalable infrastructure. So some of the VPC concepts are the virtual private cloud. It's known as VPC. It's a virtual network dedicated to your account, AWS account. There's a subnet, which is a range of IP addresses in your VPC. Then you get a route table, which contains a set of rules called routes that are used to determine where network traffic is directed. Then you have an internet gateway, which is a horizontally scaled, redundant, and highly available VPC component that allows you to communicate between instances in your VPC and the internet. So it therefore imposes no availability risks or bandwidth constraints on your network traffic. Then you have something called a VPC endpoint, which enables you to privately connect to your VPC to supported AWS services and VPC endpoint services powered by private link without requiring an internet gateway, NAT device, VPN connection, or AWS Direct Connect. So instances in your VPC do not require public IP addresses to communicate with resources in the service. So for now, those are essential components you should know. So there is a virtual private cloud, which has a subnet. It also has a route table. There's an internet gateway, and there are endpoints. Now let's move to the last for this video, which is VPN, which is a virtual private network. So by default, instances that you launch into your VPC can't communicate with your own remote network. You can enable access to your remote network from your VPC by creating an AWS Site-to-Site VPN connection and configuring routing to pass traffic through the connection. So although the term VPN connection is the general, VPN connection refers to connection between your VPC and your on-premise network. Site-to-Site VPN supports Internet Protocol, which is IP VPN connections. So the concepts to remember are: there's a VPN connection, which is a secure connection between your on-premise equipment and your virtual private clouds. in AWS. Then you have a VPC tunnel, which is an encrypted link where the data can pass from your remote network to your AWS. So each VPN connection includes 2 VPN tunnels, which you can simultaneously use for high availability. Like if one fails and the other one works. Then you have Customer Gateway, which is an AWS resource which provides information to AWS about your Customer Gateway device. Then you have a gateway device, which is a physical device or software application on your side of the site-to-site VPN connection. So how do you connect to this? You can use the Management Console, CLI command line interface, SDKs, or Query API. So the site-to-site VPN limitations, it only supports IP version 6, as if you recall. It's like the 3-digit, three numbers, and then one number, and maybe 2 or 1 numbers. And it's an AWS VPN connection, does not support MTU, path MTU discovery. This I will discuss in a later video. So for now, those are the important components you should be well aware of: the API gateway, Direct Connect, Elastic Load Balancing, Route 53, VPCs, and Cloud Map. So please like, subscribe to my video, and I will continue making more. Bye. See you next time.